This video is on definite integrals. In order to discuss how to evaluate a definite integral, we need to have the fundamental theorem of calculus part 2. This states that if f is continuous on an interval from a to b, then the integral from a to b of f of x dx is equal to capital F of b minus capital F of a, where capital F is any antiderivative of lowercase f. In other words, capital F is a function such that capital F prime is equal to lowercase f. Geometrically, the definite integral represents the area underneath the curve of f provided that f is positive. Let's do an example. We're going to evaluate the integral from 1 to 4 of 3/2 times square root of x minus 4 times e to the x. Now, before we can evaluate this and apply our antiderivative rules to find an antiderivative here, I am going to rewrite this integral. So the first term in the integral, instead of writing square root of x, I want to write x to the 1/2. And so now I need to find an antiderivative. This function that we're trying to integrate is comprised of two terms that are subtracted. Whenever you have multiple terms that are added or subtracted, you can find the antiderivative of each term separately. So we're going to focus on this term first. 3/2 is a constant multiplier, so it will remain in my antiderivative as a constant multiplier. For x to the 1/2, I'm going to use the antiderivative power rule, and it states that we need to increase the exponent by 1. So x to the 1/2 becomes x to the 3/2, and we divide by the new exponent. However, dividing by 3/2 is the same thing as multiplying by the reciprocal 2/3. So that is the antiderivative of the first term in the function. For the second term, we have also a constant multiplier of 4, so that will come down as a constant multiplier in the antiderivative. And then we have e to the x. Our antiderivative rule for e to the x says that it is its own antiderivative, so we have that. And we want to evaluate this at 1 and 4. If you remember from the fundamental theorem, it says that we want to evaluate the top bound first and subtract off the bottom bound. So first I'm going to plug in x equal 4. On the first term, 3/2 times 2/3, that gives me 1. So that term just simplifies to 4 to the 3/2 minus 4e to the 4. And now we're going to subtract off the bottom bound, so that's going to give me 1 times 1 to the 3/2 minus plus 4e to the 1. This is going to be a plus because we are subtracting from the bottom bound, so we would have minus and negative does make that positive. This can be simplified a little bit. 4 to the 3/2 is equal to 8. 8 minus 1 gives me 7 minus 4e to the 4 plus 4e. Let's do another example. This problem asks us to find the area under the curve y equals sine x with x between 0 and pi. I stated earlier that a definite integral represents the area under the curve, so what this problem is asking us to do is to calculate this integration. So I'm going to need to find the antiderivative of sine, and it turns out that that is negative cosine. And now we'll evaluate negative cosine at these bounds. So plug in the upper bound first. I have negative cosine of pi, and subtract off the bottom bound. Since we are subtracting a negative, that's going to become a plus cosine of 0. Now, cosine of pi is equal to -1, but there is also a negative out front of there, so that is going to give me negative of -1, or positive 1. And cosine of 0 is equal to positive 1. So this tells me that the area underneath this curve between 0 and pi is equal to 2.